Once you finished running your simulation, you may want to visualize your trajectory in a tool like VMD. However, it is not that simple. After you have loaded your trajectory into VMD and configured your representations, you will typically start running it, and you will see that all the molecules start jumping all around the box from one side to another, like they're being stretched all over the box, and it seems like something went wrong in some stage, and your trajectory is now totally full of artifacts, and it can be scary, but don't worry, as this is all because of periodic boundary conditions. Even with computational capabilities of modern hardware, it is still impossible to simulate complex systems in an infinite space. One way to tackle this problem is to use periodic boundary conditions. Instead of simulating the infinite space, we only focus on a small part of it, which is our system of interest, bounded by a simulation box. Imagine that there are multiple such boxes located in a grid, one next to other, and once our molecules flow out of one such box, they simultaneously flow into another box located just next to it. And each such box is like a mirror reflection of another box. Basically, this is what you can see when you visualize such raw trajectory with periodic boundary conditions. Your molecules just jump from one side of the box to another side of the box due to flow, and this leads to such visual artifacts. Not only these artifacts complicate your observations, they also lead to miscalculations when you analyze your trajectory. This is why most of the GROMACS tools have built-in a function of removing periodic boundary conditions and aligning your molecules and centering your region of interest of your system in your simulation box. Now, if you are dealing with a complex system, these built-in measures might not work. So you want to pre-process your trajectory beforewards. Plus, you might want to remove solvent molecules and ions from the trajectory, as you don't need them anymore, unless you are doing some specific studies. There is a tool in the GROMACS suite created specifically to handle different trajectory operations, and this tool is called GMX trjconv. For small systems, when you deal only with one protein, you can make it all in one run of the trjconv. So you will typically align your protein, center it in the simulation box, and you will remove a periodic boundary condition. Plus, you can also remove solvent. However, as I am dealing with a complex system in this particular scenario, I will do it all in 3 steps. So I will first remove periodic boundary conditions. Then I will center my complex. And only after that I will align to avoid any possible artifacts. Now finally we can visualize our fixed system, and as you can see, there are no jumps anymore. Periodic boundary conditions were removed. Our complex is centered in the simulation box, and there is no water or ions, and everything is perfectly aligned now. Thank you for your attention. Please let me know if you had any trouble.